Okay, now just a reminder that the IB syllabus defines the lattice energy as the other way around, where they break the ionic solid. So it's similar to bond energy, where it's defined as the bonds broken. So anytime you break a bond, it will be positive. If you form the ionic bond here, for example, Na plus Cl minus a gas and get the ionic solid, then this would be negative with the same value. So the magnitude is the same, but the direction is different. So if you break an ionic bond, it will be positive, and if you form the ionic bond, then it will be negative. Okay, so back to the Born-Haber cycle. So I'll just show you again. First, we'll start with the elements. Na, solid, and Cl2, gas, are the elements. So you do have to know by heart the elements of Na and Cl. We only need half of it because we only want to make one NaCl. So that would make enthalpy change of formation of NaCl, because we form it with the elements to form a mole of substance. So this is enthalpy change of formation. Okay, first we're going to atomize the Na. And the definition for atomization is you have to start with their elements and it has to form a mole of gaseous atoms. I didn't do anything to the chlorine, so I'm just going to copy the chlorine. Next, I'm going to atomize the chlorine. So I get a mole of chlorine, but if you haven't noticed, this is equivalent with bond energy, but not exactly the bond energy, half of it. Okay, why do I say it's half of bond energy? Because bond energy, you will need to break a mole of covalent bond, and now we're only breaking half a mole of covalent bond. So enthalpy change of atomization of chlorine here is the same as half the bond energy of chlorine gas here. And it's only valid if their elements are in gas. For example, if it is bromine, the elements is in liquid, so it wouldn't be half the bond energy. So we'll need to put enthalpy change of atomization here. Okay, since I didn't do anything to the Na, I'm just going to copy it. Next, I'm going to ionize. So first, ionization energy of Na to get Na plus in gas. So the electron came out. I didn't do anything to the Cl, so I'm just going to copy it back. So that electron came out of Na, now Cl is going to take it, and downwards means exothermic, so this is electron affinity of Cl. And so I get Cl minus in gas. I didn't do anything to the Na now, so Na plus still. Okay, so with reference to the lattice enthalpy that I showed you just now, which is to form, to break a mole of ionic solids. So to break would be this direction. So this lattice energy would be positive, or rather endothermic. So I'll put a label there. Going up is endo, and going down is exo.